Addition and subtraction of rational expressions. Addition and subtraction of rational expressions is really just like adding or subtracting fractions. The key is that we must have a common denominator. So if we were asked to simplify the expression x over x plus 4 plus 2 over x, we first notice that they do not have a common denominator. And since these two denominators do not appear that they can be factored any further, what we can say is that the LCD is simply the product of the factors. And so it would be x times x plus 4. So as with simple numeric fractions, we now need to build up each of the fractions by the appropriate factor. So we have the original x over x plus 4. That is missing the factor of x in the denominator. So I will multiply that by x in the denominator, and I have to multiply by x in the numerator as well. Plus, we have 2 over x. Alright, so this has the x, it's missing the factor of x plus 4. So multiply by x plus 4 in the denominator, and x plus 4 in the numerator. So then this would give us x squared. We simplify the numerator, leave the denominator alone. X squared over x times x plus 4 plus 2x plus 8 over x times x plus 4, which simplifies further. See, now we have common denominators, and so now we can add the numerators, yielding x squared plus 2x plus 8 over x times x plus 4. And it is common practice to simplify the numerator and to leave the denominator in the factored form. So here's the second example. 2x over x minus 5 minus x over x plus 5. So now, our LCD, as before, since it doesn't appear that we can factor these any further, the LCD would be x minus 5 by x plus 5. The first fraction, 2x over x minus 5, the denominator is missing the factor of x plus 5. So we build up both numerator and denominator by the factor of x plus 5. Minus, we have the x over x plus 5. This fraction is missing the factor, the denominator is missing the factor of x minus 5. So we multiply both numerator and denominator by x minus 5. So now this would give us 2x squared plus 10x over the denominator, x minus 5, x plus 5, minus x squared minus 5x over x minus 5, x plus 5. Now we can subtract the numerators. Now be careful here. Remember, when you subtract polynomials, you're really adding the opposite. So I'll go ahead and write that out here. I've got 2x squared plus 10x. And now, really what's happening here is I'm taking this subtraction and I'm distributing it through both terms in the second polynomial. So it would be minus x squared plus 5x. And that's all being divided by x minus 5, x plus 5. I've subtracted the numerators over the common denominator. And so then simplifying the numerator, 2x squared minus x squared is x squared, plus 10x plus 5x is plus 15x, over x minus 5x plus 5. Example 3. Here we are asked to simplify 3 over x minus 1 times x minus 2 plus 4 over x plus 1 times x minus 2. Again, let's determine the LCD first. Alright, so we look at the factored forms on the denominators, and we see that the first fraction has factors of x minus 1 and x minus 2, and the second fraction has factors of x plus 1 and x minus 2. So we see the x minus 2 is contained in both of them, so we don't need that. We do need that as part of the common denominator, but we don't need to add it to either of the fractions. But what I sort of see here is that the first fraction needs a factor of x plus 1, the second fraction needs a factor of x minus 1 for them to be common. Now, if you really wanted to go through this, the LCD would be x minus 1 by x minus 2, all of the factors from the first denominator, and then we don't repeat any factors that are in the second, so we don't repeat the x minus 2, but we need an x plus 1 as well. So the LCD is x minus 1 by x minus 2 by x plus 1. So what I now need to do with that is kind of say, well, what was missing? The first fraction was missing the x plus 1, so I'm going to add it in. Well, multiply it in, really. So I have 3 times x plus 1 over x minus 1, x minus 2, x plus 1, plus, now the second fraction, the denominator was missing the factor of x minus 1, so I'll multiply that in. Alright, and now we're done with the tough part. The rest is being careful. So I have now 3x plus 3 over the denominator of x minus 1, x minus 2, x plus 1, plus 4x minus 4 over the denominator x minus 1, x minus 2, x plus 1. And now since it's addition, I'll write 3x plus 3 plus 4x minus 4 over the denominator. And simplifying the numerator gives me 7x minus 1 over the common denominator, x minus 1 by x minus 2 by x plus 1. Alright, and the fourth example, we have 3 over x squared minus x minus 6 subtract 2 over x squared plus 5x plus 6. Notice how this one's a little different than the previous example, but really the difference is the denominators aren't in a factored form. So let's put them in a factored form. X squared minus x minus 6 factors as x minus 3 by x plus 2. X squared plus 5x plus 6 factors as x plus 2 by x plus 3. So using the same sort of ideas in the previous exercise, my LCD is x minus 3 by x plus 2. I don't need the repeated x plus 2, but I need another factor of x plus 3. So the LCD is x minus 3 by x plus 2 by x plus 3. So I can rewrite this as 3. Let's see. The first fraction had the denominator x minus 3, x plus 2. It's missing the x plus 3. So 3 times x plus 3 over the denominator of x minus 3, x plus 2, x plus 3. Subtract the 2. Now what's missing in the second denominator? The second denominator is missing the x minus 3. Alright, so now I can start to simplify this. I'd have 3x plus 9 over the denominator minus 2x minus 6 over the denominator Alright, now we're subtracting. So I'd have 3x plus 9 minus 2x plus 6 again over the denominator. X minus 3, x plus 2, x plus 3. And combining like terms in the numerator would give me x plus 15 over the denominator x minus 3, x plus 2, x plus 3.